Hello everyone, welcome back to Study Hall. Today we will going to start this chapter Gravitation, which is chapter number 10 of your NCERT science book, class 9th. So in your previous chapters, you have learned about the motion of objects and the force as they cause the motion. We have learned that a force is needed to change the speed or the direction of motion of an object. We always observe that an object dropped from a height falls downward the earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, there must be some force acting on the objects. So let's start with the topic of gravitation. We know that the moon goes around the earth, right? An object when thrown upward, it reaches to a certain height and then falls downward. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of an apple made Newton start thinking that if the earth can attract an apple, can it not attract the moon? Is the force the same in both the cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. So it must be attracted by the earth. But we do not really see the moon falling towards the earth. Let us take some more examples, students. Let us take the example of thread. When you release a thread, the stone moves in a circular path with a certain speed and changes direction at every point. The change in the direction involves change in the velocity, or you can say it as an acceleration. The force that causes this acceleration and keeps the body moving along a circular path is acting towards the center. And that force which is acting towards the center is called a centripetal force, which is also known as a center-seeking force. Gravitation, it is the force of attraction between two objects in the universe. Between any two objects in the universe. So in gravitation, it is the weakest force and it acts due to the masses of the body. Come to the next topic, which is universal law of gravitation. So according to this law, every object in the universe attracts every other object with a force which is proportional to the product of their masses and is inversely proportional to the square of the distance between them. The force is along the line joining the center of the two objects. Let us understand this law mathematically. Suppose this is your object 1 and this is the object 2. Let us suppose this is Earth and this is your moon. Now according to this law, the force is directly proportional to the product of the masses of the objects. So let us suppose the mass of Earth is m1 and the mass of moon is m2. Now the force is also inversely proportional to the square of the distance between both the objects. So students, from equation 1 and 2, we get force is directly proportional to m1 into m2 divided by r square. We have to remove this constant or proportionality sign by putting the constant or proportionality value. So we use the capital G, which is constant of proportionality and is also known as universal gravitation constant. You can also see the value of capital G, which is 6.67 into 10 to the power minus 11 Newton meter square per kg square. You can calculate the SI unit of capital G from this equation. Capital G is a gravitational constant and it is denoted by capital G. The value of capital G is, the formula of capital G is, you get the formula from this equation, which is force into r square divided by product of the masses of the object. You can calculate the SI unit of this gravitational constant by using the SI unit of these. The SI unit of force is Newton and the SI unit of distance is meter, as this is meter square. And what about the SI unit of mass, student? It is kg. So from this you get Newton meter square per kg square. I hope it is clear, students. Now we have to discuss the SI unit of gravitational constant, which is Newton meter square per kg square. So the value of capital G is, universally accepted value of gravitational G is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. This experimentally determined by Henry Cavendish. This scientist determined the value experimentally. Now come to the significance of universal law of gravitation. You can also say that the importance of universal law of gravitation, the force that binds us to the earth, the motion of the moon around the earth, the moon of the planets around the sun, and the tides due to the moon and the sun. Let's talk about the history of planetary motion. So Ptolemy is the first scientist who had discovered about the geocentric model, in which he concluded that all the planets, stars and sun revolve around the earth. Now, some Indian astronomers explained the heliocentric model, in which they concluded that the planets revolve around the sun. Nicholas Copernicus model also comes after this, in which he concluded that the planets move in a circle around the central of the sun. Brian model also comes in the existence, in which they conclude that they spent their lifetime recording observations on the planets. And at last, Johannes Kepler's come in the existence, and in which he concluded that Kepler's law were basis of Newton's universal law of gravitation, which you have. So let us discuss about the Kepler's first law, which is law of orbits, in which he explained that the orbit of every planet is an ellipse around the sun, with sun at one or two foci of the ellipse. Now let us second law, which is the law of areas. Kepler explained that the line joining a planet to a sun sweeps out equal area in an equal interval of time. Let us suppose this is sun and this is your planets. So according to this law, he concluded that the line joining in a planet to the sun sweeps out the equal area in an equal interval of time, as you can see it here. Now the third law, which is given by Kepler, is law of periods. So in this law, Kepler concluded that the square of the time period of a planet is directly proportional to the cube of the semi-major axis of the orbit. As you can see it here, that the square of the time period is directly proportional to the cube of the semi-major axis of the orbit of any planet.